All right, so now we have looked at the processor, CPU, the active components of the CPU. We saw the diagram. Block. Now we are going into registers. Okay. The other components of the CPU are the registers. These are storage components which, because they are placed very close to the ALU, allow very short access times. So these storage places are kept very close to the ALU. So no distance to travel. Because you might wonder what is the distance. Uh, that's a very short distance, about 1 millimeters. But the thing is, even that is too much for such a high-speed computer. That one instruction missing, that makes a big difference. So because of that, now these ALU registers are kept close to the ALU so that you can work very fast, allow very short access time. Short access time means high speed. Each register has limited storage capacity. As I told you, it's just tiny things, right? Typically 60, 32 or 64 bits. 16 bit, 32 bits, 64 bits. Right? Register. A register is either general purpose or special purpose. This also I mentioned at the beginning. Just check your memory. If there is only one general purpose register, it is referred to as the accumulator. So, where do you get these for the exam? You will get under low level instructions or low level programming, assembly programming. You will get these things. So, accumulator is called ACC. There's only one register, and that will be accumulator, general purpose, right? General purpose. Here and in chapter 6, we assume that the processor has just this one general purpose register. So we think that there's only one register, one general purpose register. The accumulator is used to store a single value at any one time. That is one thing that you have to remember. The accumulator, if it's like a box, or small thing that you will remember also that. Very long process or a very small register. Right? So you have what do you have in this? The accumulator is used to store a single value at any one time. So if you are adding up like a equals 10, so you will have 10 here, right? Then another place, another register or something called A. So for that A, this will be stored. There will be another instruction to put this into A, another place, another square like this register. So, but only one. Now, if you are going to add this, what happens? You have another place called say D. Copy this place is called what? D. Is D. This is accumulator. A, C, C, usually called like that. So it will come here 10. Then uh, You put the 20 also there and then add it. Huh? Then it becomes 30. Then when you put the another 30, sorry, 30 and then another 30 comes by way of C, it will become 60. Then it will be put this will be stored in D. That's how D equals A plus B plus C is A, but only one figure can be kept there. It's obvious, no, when you look at it. Can you put like this 20, comma 30 or 10? You can't do that. Not like a box containing apples. Huh? So, see, so that is very important to understand because when you are doing the low level programming, it will come in. Accumulator is used to store a single value at any one time. A value is stored in the accumulator that is to be used by the ALU. So ALU will make use of that. For the execution of an instruction, the ALU can then store a different value in the accumulator after the execution of the instruction. So when you finish that, now you can do something else. So then you can even A, if it's a string character or something like that, A, then the accumulator. Have a look at that again. A general purpose register. So then will you please remember that accumulator is a general purpose register? Because there are others which are very specific, right? So accumulator is a general purpose register that stores a value before and after the execution of an instruction by the ALU. So what? Let's look at when the this 10, when you have to add this D equals A plus B, 10 will come here, right? Then what happened? Before and after. So after adding it's 60. Before also it's stored and after adding also it's stored here until it uh, is transferred to the storage place D. D equals this, so it will go to D. Then also it will be there, but if you need another execution of another instruction, then this will be erased and the new value will come. Figure 5.01 shows some of the special purpose registers. Where is here? Figure 5.0, table 5.01 registers the simple CPU. But this says figure. Let's figure. Figure 5.02. This should be figure. Yeah, that's be figure. You can't straight away go to you have to start with 501 figure. Next. Yeah, 5.01 and highlight in red this word table. Okay. So what does the figure 5.01 give? Special purpose registers. special purpose registers as individual components. The box labeled other registers can be considered to comprise the accumulator plus the special purpose registers not identified individually. Comprise means they contain, like contain the accumulator plus the special purpose registers not identified individually. So a collection. The full names of the special purpose registers included in the simple CPU that we are considering are given in table 5.01 with a brief description of their function. Okay, now here we go. Now this is table 5.01. So I was wrong. This is wrong. Then where is figure 5.01? Let's look at figure 5.01. Let's search. Here it is, figure 5.01. Okay, the one that we saw, right? So earlier one I did was wrong. Figure 5.01, the special registers I told you, as the textbook says, the special registers are mentioned. We already saw. No need to go come back here even. And other registers are there. It's a collection. The general, see the general purpose register. Now that we came here, it mentioned, if you can remember, general purpose register, the accumulator, and other registers. So the accumulator also is here. These are the specific ones, special purpose. There is a special purpose for this memory data. So let's go to the place where we stopped. Yeah, figure 5.01 shows some of the special purpose registers as individual components. Now see whether you can remember. What are the special purpose registers which we saw in that figure? MDR, MAR, CIR, correct? Good. MDR is memory data register. M for memory, remember. MAR is memory address register. CIR is current instruction register. The box labeled other registers, remember? There was another box called other registers, can be considered to comprise the accumulator we are talking about, plus the special purpose registers, not identified individually. So they are not identified individually, they are all together like a collection. The full names of the special purpose registers included in the simple CPU that we are considering are given in table 5.01 with a brief description of their function. So let's look at the table and see what are the registers which are identified. The details. Register name, current instruction register. Already familiar, remember, CIR. And what's the function? Stores the current instruction while it is being decoded and executed. I told you about decoding. Before executing, you have to decode what is to be done. How much of electricity, uh, what is the voltage to be done? That is 0 or 1. Voltage, you say no voltage is 0. No, it's not correct. Low voltage is 0 and high voltage is 1. Just out of the topic, but just for your knowledge. If it's like, say for example, 5 volts and 3 volts. If you are taking electrically, the binary code will be 5 volts and 3 volts. 5 is the high voltage, which is 1. And 0, not 0, 3. 3 is the low current, which is the 0. Okay. So you have to prepare the instruction, the electrical signal to be sent by the control unit to uh, execute the instruction electronically bytes. Sorry. Then index register IX, was not mentioned earlier. CIR was mentioned, but IX was not mentioned. Stores a value only used for indexed addressing. Learn later. Now, no hurry, but it's called indexed addressing. IX, how do you remember? First letter of index is I, last letter of index is X. First and the last. Memory address register, MAR, already mentioned. Can you remember? I mentioned MAR, memory address register. Stores the address of a memory location or an IO component which is about to have a value read from or written to. What is that? Big sentence, no? Stores the address of a memory location. All right, that you understand. Like in Excel or OpenOffice Calc, you have A1, B10, K11. Those are addresses, cell addresses. Same way, the memory also in cells. The data is stored in cells. So, stores the address of a memory location or an IO component. What is IO component? IO, what is this? Input and output. Input or output component, which is about to have a value read from or written to. The address of that component. Memory data, the MDR, also called MBR also, because of the buffer. Memory data register, this MDR. Another word is MBR for memory buffer register. It's the same. Stores data that has just been read from memory or is just about to be written to memory. So either read from memory or to be written to memory, that is there in the MDR. Right? Program counter, PC, I told you it's not personal computer, it's program counter. Excuse me. Talking, my throat becomes dry. Program counter stores the address of where the next instruction needs to be read from. All these are mentioned, in the summarized form. Even if you miss this part, you will know. I have already taught you all these things, but these are details which will enhance your knowledge. So the address of where the next instruction is to be read from. So the instructions are kept in addresses. So what is the address of the next instruction? Then status register, SR. This was also not there. SR and IX were not there in that earlier diagram, which is figure 5.01. What does it contain? SR, bits that are either set or cleared, which can be referenced individually. Like now, the status bar here is a status bar. No? What do you have here? The Zoom mic is on, language, Wi-Fi, speaker, battery. Oh, yeah, it's being charged. So the status is given there, the time and all that, something like that. Here also about the system, what is going on now, is status. Contains bits, individual bits, like this bit for, I say, I remember, or when you're flying in a plane or you go to a hotel and in a room, if you press the attendant button, press the button for attention, the room fellow, the reception, that fellow knows which room it rang from. Which room is calling. Otherwise, we'll have to go to every room and knock and ask, did you call me? Tuck, tuck, tuck. Did you call me? Knock, knock, knock. Did you call me? That's not necessary because it indicates which room call. A very simple mechanism. So something like that is also there in this status register. Contains bits that are either set or cleared. So which means either 0 or 1, which can be referenced individually. If this bit is on, something. If the other bit is on, if the other bit is 0, like that, the status. What is the status of each? There are three important points to remember. First is that the MDR must act as a buffer. Buffer, what is buffer? Where have you heard this word buffer? Have you heard the buffer in a car, in a vehicle? Buffer front and behind. So when you knock against another vehicle, there's a buffer, like cushioning off, or right? Then a buffer stocks. Have you heard of buffer stocks? You are not using it, but keeping it for an emergency. So like that, this is a buffer, a temporary thing. Right? MDR must act as a buffer. This is because transfer of data inside the processor take place much more quickly than transfers outside the processor. Difference in speeds. Difference in speeds. That is the reason. Why do you need a buffer in a vehicle? Because difference in speeds can. The first one is going and the second one is going faster than the first one. And behind, without avoiding it, if it goes behind, it will knock because the speed is different. That is why you have the buffer to absorb it and then to avoid damage to the vehicle. Same way here, inside the processor and the outside the processor, data transfers are at different speeds. So therefore, you need a like a hold, wait. This one doesn't come yet. Wait till he comes, like that, not synchronizing, but you need to act as a buffer. You have to wait. And also streaming a video. There's a buffer. Downloading a video from the YouTube, you will see the red line going, playing so much. Then in front of that, the white, gray bar is moving. This is playing, the red one. The ash one is buffer, which is loading into the memory, showing this part. If those two come together, it will pause for a minute, pause for a moment, until the white one overtakes again, goes one. Because there is nothing to be played. You have played everything that is downloaded. Buffer. The second point to note is that the index register, that is IX, you are familiar now, IX index register, can be abbreviated as IR. These are the things, they are making it difficult for us, isn't it? Abbreviated to IR because index register, I for index and R for register. Okay, so what to do? We'll have to remember that also. Abbreviated as IR. But in some sources, the current instruction register, CIR, is abbreviated as IR. Now see. What are they doing? Making things difficult for us. This is a potential cause of confusion. Yes, we know. That's what we are saying. In this book, the index register is always IX. Some consolation. No. In this book, the index register is always IX, not what is the other one? IR, not IR, this abbreviation. In IX, and the current instruction register is CIR. So finally, there is consolation. So you must remember, don't get confused with this IR and all those things. Finally, there is also possible confusion if the abbreviation PC is used. This will only be used in this book when register transfer notation is being used, as you will see later in the chapter. Everywhere else, a PC is a computer. So in this chapter, We are doing the program execution, fetching, decoding, executing, and all that. The components, we have to consider it as program counter. Everywhere else, PC is a computer. What computer? Personal computer. For all of special purpose registers, except for the status register, the contents represent one value. So which one can have more than one value? For all of the special purpose registers, except for the status register. Okay? Except for the status register, the contents represent one value. So all these registers only one value, but um, let's say we'll copy this and have another. If you have this SR, we'll call it SR. SR. What does SR stand for? Status register, excuse me. In that only, you can have many values because they are taken as individual values. You remember, if you remember well, we talked about it, individual values. If say if this is on something, if this is on another thing, if this is off, it's another thing. So individual ones represent different. Because of that, the status register only can have many uh, values. Right? For the status register, each individual bit is used as a logical flag. There's a flag. So if the first bit is on, maybe the the lift is going up. Right. If the second bit is on, right, you have pressed the button. Third is on, which floor? Huh? It's third floor. Or let's take first bit is on, it's first floor. Second bit, second floor. Likewise, there's some indication, some flag. The bit is set to 1 if a condition is detected. So if there is a particular condition detected, if the condition is set, the bit is set to 1. Examples are the carry flag, the negative flag, and the overflow flag. So carry flag is what we'll be doing with logic. Yeah, you'll be doing later more. But at the moment, if there is an addition, binary addition we have done, remember binary addition? So if you add 1 plus 1 is 1, 0. You put the 0 as a sum and 1 carried to the next column. So how do you know? You have to have it as a flag. There is a carry. Carry bit is 1. Okay? That is how it works. Very simple operation. The bit is, examples are the carry flag, the negative flag. If it's a negative, if the number is negative, you deduct some bigger number from the small number, it becomes negative. Or overflow flag. There's a thing called overflow also. We learned in chapter 1. Overflow. If there are 8. Now, this is the best place to think of that. We didn't go into details. Now see, this register has, you are supposed to add another one. Let me double this. What will happen here? Either 0 or 1, and this here this will be 1. An overflow. Additional one will come. The carry one will come here. So there is an overflow. We learned about that. Chapter 6, so the next chapter, contains some examples of the use of the accumulator and the status. That will be very interesting. The assembly programming language instruction. Very interesting. And now the next one is system bus. This should be done for the next lesson, right? This should be done for the next lesson. So thank you very much for watching this video. Wait, the next one, next time. See you. Bye.